Okay, thank you very much, Kathy and Lou, for this opportunity to talk about the GOESR. I know that you had a previous presentation with Amanda about this new satellite will be launched next year, but I would like to give you a different approach looking at what will happen with GOESR in Central and South America. And I would like to give you at the end of my talk some kind of roadmap, what we need to do from now to the launch of the satellite and the operation of the new satellite from our National Weather Service to get ready to receive the new data. So let me start with this. Well, my name is Daniel Villa. I am researcher at INPE, National Institute for Space Research in Brazil. And I will talk a little bit about the new satellite. The new geostationary satellite will cover the Americas. So first of all, the GOES satellites are designed and are operated by NOAA. So we here in Brazil, we are not operating. NOAA NESDIS has the mission to deliver accurately, timely, and reliable satellite observation and integrated product to provide long-term stewardship for global environmental data in support of the NOAA mission. So this is something very general about the mission of NOAA, and inside NOAA, NESDIS is the agency, the specialized agency who deal with satellite data inside NOAA. So here we have some kind of picture of the global satellite observing system, where we have several in the middle of this. Let me check here. Okay, fine. Let me see if I can. So we are here several geostationary satellites. And well, we will have a new one around here. NOAA will decide at the end of the process which position will put the next GOESR. But the basic idea is that we have this satellite that cover the whole world. We have a global picture with all these satellites flying in the geostationary orbit. So this is some kind of the history of the GOES satellites. The GOES satellites, before being launched, are designated with letters, because this is because we have right now the GOESR. So, and once the satellite is launched successfully, it's redesignated with a number, 1, 2, or 3. So the GOESR will be, in case they will be launched successfully, will become GOES 16. So if you are interested in the process, you can see, from the GOES 1 to the GOES 16, all the different constellation and different technologies inside the geostationary satellites. So this is what we have right now. We have a GOES East at 75, and we have GOES West at 135. This is something that everybody knows. So the good news right now is that we will have a new satellite when we launch, will be in the 90 degrees west. So this will be the checkout position. So the satellite will be launched, and the satellite will stay in that position during the checkout that will take around 6 months. So this is this time the NOAA will take care of the satellite and will fly the satellite and will test all the system inside. So this will be a test time for NOAA, but perhaps some of us can get some imagery from GOES, and this is what we will have. This is if GOESR will be at 90 degrees west, this is the picture we will have. And this is one of the options that also NOAA is considering to put the satellite waiting for the next satellite, because in this series we have two satellites. We have GOESR and GOESS. So once they launch GOESS, they split to east and west position. But this is some kind of central position, and we can see that most of Central and South America is covered. Perhaps some region in northeastern Brazil we have a very high angle, but we can also complement this information with CVD data from Meteosat that is close to zero. So we can figure out how to deal with that situation in case they decide to put the satellite in 90. But this is not sure. This will be here. The satellite will be here during the checkout, but there's no information about what will happen after the checkout. The official word of NOAA said it depends on the health of the system. So they will check what happened with the other satellites and see what will decide to do. So why we need GOESR? Because GOESR is a new generation of geostationary satellites for the Americas, and we have several sensors. The main one is sensor in a geostationary orbit for lightning monitoring, and also we have some sensor related with space weather monitoring. So we are, as meteorological community, we are not much interested in these kind of things, but of course we are interested in these, of course, and these. And I will show you some example how we can combine those informations. So moving forward with my presentation, this is how the spacecraft looks like. We have all the instruments inside. So this is some kind of cartoon of how the spacecraft look like, but it's not very important. The important thing is that we have these two sensors, ABI, Advanced Baseline Imager, and the Geostationary Lighting Mapper, GLM, that these are these two sensors we are really interested in. So this is the ABI. This is 16-channel imager, ranges from the visible to the near infrared wavelength, improve every product from the current GOES imager, and we offer new products and severe weather forecasting, fire, smoke monitoring, volcanic ash advisories, and more. So as Amanda told you in her presentation, the capabilities in terms of spectral information is 3 times, in spatial coverage is 4 times, and temporal resolution is 5 times. So if we multiply these numbers, is 5 by 420, 3 is 30 times what we have right now. This is also very challenging for us as weather National Weather Service, how to deal with the amount of information that we will receive, because we will receive much more information that we are receiving right now. So we made some kind of rough calculation about how many data we will receive per year, and the first number is around 1.2 petabytes per year, just only the raw data. I'm not including the images. Once you process and get the images, and you get the products. So this is something that will be very challenging for us as National Weather Service, how to deal with that, and we need to be prepared for getting that information. It is 30 times what we have right now. So this is very challenging, and I will show you more challenges we have in our way. So this is what we have right now on the right side, and what will we have in the left side. So 5 bands against 16, and we have the spatial resolution is improved for all wavelengths, and right now we have 3 images per hour. This is the compromise for NOAA with the WMO, and with GOESR we have 4 images per hour at least. So, but what we can get, if we go to another mode, we have 1 image every 5 minutes. So this is something that we need to think about. So this is what we have right now. We have 5 channels, and most of the forecaster who works with GOES imagery is the main channel is the visible, this one, the visible, the water vapor, and IR. So we used to see these 3 channels only. So you can imagine when we have this, we have 16 channels with GOESR. So if it's a problem sometimes, it's a problem with time also, because the forecasters are very stressed with time. It's problematic to see 3 channels. You can imagine with 16. So the basic idea to work with all this information is try to summarize information in some way. So what I will show you a little bit how we can deal with this amount of information, because this amount of information give us more products, give us more information about what happened in the cloud. For example, we have information about microphysics. We have information about, for example, volcanic ash. We have information about fires. So we have a lot of information in every channel, but we cannot see every channel every time we are doing the forecast. So the basic idea is to summarize information in different kind of products. And I will show you a little bit what the people from Europe is doing for a while, is trying to summarize the information using the RGB composition and other kind of product they are using for just a long time right now. And we can take advantage of this experience to work here in our region. So for example, this is all the channels, and we have a table here with the sample used. So I suggest that you can go through these tables and see which is the wavelength for each channel, which is the nominal pixel size, and which is the sample use, which is what can we use this for, what we can use that channel. So this is something that you need to go through. I don't want to spend my time on that, because first here we have this is the information. If the GOESR will become GOESR, this is the picture we'll have. And this is some kind of animation, but it's not working in Saba, so I will go through and I will try to show you how we can take advantage of the European experience with RGBs. So the RGB is the combination of 2 or 3 channels. In sometimes it's channel difference, sometimes it's channel ratios, to get some kind of new product that is useful for example, in terms of a forecast or in terms of monitoring volcanic ash. So depending of which kind of thing I would like to do, we will use different channel combination. So this is good because this is very fast and it's quite efficient for quantitative feature extraction. So this is very useful, for example, for a forecast office, let's say, because we have more information that we have in one single channel. We have the combination of those 2 or 3 channels, and we have more information. I will show you, as I will show you in a couple of slides with examples. So the basic idea is to put one channel in each color. So we have the red beam, we have the green beam, and we have the blue beam, and we have the combination of, we can get all these colors we have in this circle. It's the combination of different amount of each color. So this is the general, the most simple example. If we have, for example, channel 1, channel 2, and channel 3, this is a Meteosat example, but this will work with our GOESR. So this is very good because all these channels are available in the next GOESR. So we can get, these channels are in the visible range. So what we can get, combining these 3 channels, is some kind of real color image. It's not exactly real color because it's not exactly the right range of wavelength. But as you can see here, the land is green, the ocean is almost blue, we have the desert here, and of course it's some kind of brown, and we have the clouds here. So we have more information that we have in the visible channel alone. So we have here a combination, and we can get this nice picture. But this is one example. This is a real color example. But also we can use, for example, this air mass product. We can use a difference between different wavelengths. All these wavelengths will be available in GOESR. So this we can use in GOESR when we get the data. And in this case, it's a comparison of potential vorticity and 300 hectopascal and the product, the air mass product. So as we can see, you can distinguish different air masses in this picture very fast, and different kind of clouds with different colors means different kinds of clouds. So this is something that it's easier to make an interpretation than a single channel that we are using right now. For example, using just only visible, only the water vapor channel we have here in the blue channel. So this is a combination, and this is something that we can take advantage of that. So of course we need some training on that issue, because of course the European Meteorological Service are working with those products for a while, for many years, but we don't know almost anything about this. So this is something we need to learn, and we need to be prepared. And of course I know that the people in Europe can help us a lot to work with that and to be prepared for the day one to get advantage of this product. This is just only a combination of different channels which will be available in GOESR. Instead of seeing each particular or each individual channel and try to extract information from that, this is a combination, and this combination gives us more information in some point that single images. This is the message I would like to send to people in the National Weather Service in South America and Central America. This information is very useful for the forecasters. Also, we have different products. This is another combination using different channels, and this is, for example, for monitoring volcanic ash. Here in South America, we know that we have a lot of volcanoes along the Cordillera dos Andes. So this product will be very useful for us. So as we can see, for example, from this difference, the volcanic ash appears with a reddish color. Here we have here, for example, but with this combination, it's appear with black color here and here, and the combination of these three give us some reddish color in the final product, and we can distinguish this from these clouds that it's convection, but this one is volcanic ash. So this is very easy for using this product to monitoring volcanic ash. It is not very simple, or it's not very easy when we use, for example, our current GOES imagery to do this kind of things. So this is something new that we will have in the, I guess, 1 year from now. So we need to be prepared, and we need to be trained about this new world that's open to our eyes. So this is another example. In this case, it's just using difference. This is just only a difference between different channels. This is something that we are working here in Septec. This is one of our colleagues is working with that. So here we have the overshooting tops using the difference between these two channels. We can use these channels are currently available in our GOES satellite. So this is something that we can do right now. But of course, if we can use a different all other channels that will be available in GOESR, we can distinguish, for example, water cloud from ice clouds. We can distinguish thin cirrus for the deep convection that we have here. Deep convection we have here, excuse me, but we have deep convection here, and for example, we have water clouds here. So this is something that we can do, and of course, this means something for the forecaster, because we can make a correlation between this and the rainfall on the ground. So this is a new world that appears to our eyes, and we need to be prepared for that. So, and of course, we also will have GOESR. The GOESR program will provide with some kind of products that will be available. Exactly this, the products will not be available for us. The algorithms that will create those products will be available for us. So the basic idea is we will receive the imagery, and I will talk a little bit later about new algorithms that will be available free of charge. This is very important. All the algorithm to create this baseline product and future capability will be available free of charge. So we don't need to. Most of the providers for the reception device will give us some kind of package to do that. But this package is free of charge. This is not something that is developed for a particular company. This is developed in and we available for everybody. And this is also free available in the web page of GOESR. So if someone, for example, is interested in some of this algorithm and see how this algorithms works, for example, I would like to see, for example, a derivative instability index or rainfall rate, QPE. So I can go to this page, http GOESR.gov resource docs, and go to ATBD, and you will see all the documents and all the algorithms described very carefully by the GOESR team to understand how all these products are created. So it's good that you can look at the page and see these products. So this is something about this spatial coverage we will have. As I told you before, we will have two different modes. The first mode is one full disk every 15 minutes plus 5 minutes CONUS images. It's just only useful for United States. And one 30-second mesoscale mode, or two different mesoscales every 1 minute. So this is something that it's very different what we have right now. So if we can get in the worst case scenario, we will have one image every 15 minutes. But the GOESR also can operate in the full disk mode, that in this case we will have a full disk every 5 minutes. That, of course, this is a completely different picture that what we have right now. So this is what CONUS, the continental United States, covers. So this is in case that GOESR will become GOEST, but well, of course we need to put some image here, and this is what we have right now. And this is the mesoscale modes. So this is a very small region that we can track, for example, hurricanes, and we can get one image every 30 seconds. So I guess that Amanda talked about this, so I don't want to spend much time on this. So this is about the spectral coverage we have right now. This is something this is visible imagery, and this is MODIS. This satellite was used like a proxy for the next GOESR imagery. So this is GOES 8, this is 1 kilometer, and this is something goes with MODIS. This is the same thing we will get with GOES. So so this is something we can take into account. So this is the new world is coming. This is approximately the spectral and spatial resolution for GOES imagers. So I will not talk about this because we have enough time to download the presentation and look at the difference between the size and the new channels we have right now in comparison with the previous constellation of GOES, starting GOES 8, GOES 6 and 7, 8 and to 11, GOES 12 and beyond, OP and R. So this is also a completely new sensor. It will be the first geostationary lighting sensor inside a geostationary satellite orbit. It was designed with the experience we have with the TRIM, where we have a lighting imager in that satellite. So it detects the total lighting activity about the Western Hemisphere in cloud, cloud to cloud, and cloud to ground activity. This provides coverage over ocean and land. Of course, currently we don't have any ocean coverage because all the networks are working right now. We have some kind of dead zones, and of course it complements to the INPE system. So this is also very important for the forecaster, because if we have some information about the lighting activity, we'll give you some warnings about severe storms and of course, we improve the lead time and reduce false alarm and save life and property. So this is some kind of cartoon of this new, completely new sensor we will have in GOESR. But the point, how the text, this is something, or how the algorithm detects the lightning. So we have pixels that are illuminated in the background, and then we have some kind of merging those pixels, so grouping in different groups using some kind of space-time criteria, and the groups are equivalent to lightning strokes. So the groups are grouped into flashes. So these are several strokes. Here you have some kind of diagram how the things work. We have these particular events 1, 2, 3, 4, 5, 6. These are grouped in different groups A and V, and this group are merged together in one flash called we call A. But this is something very specific. That what we will have is the information about the lightning, and it's we will have the information on the position every 2 milliseconds. So this is really very nice for the forecaster to look at where the most convective cores are located. And this is something that how we can use information from ABI and GLM product in some kind of warning system. So we have different products from ABI. One of them is called convective initiation. So we can track which clouds have the potential to develop as a convective clouds. So with the convective convection, we also have the overshooting tops information from GOESR. All these two products are in the suite of products I showed you before in the previous slide. And we also have information about the lighting jumps. So this is coming from GLM. So we can put everything together in the next generation of warning system. And this is very useful, because of course the National Weather Service can use this information to get alarms about severe weather conditions. And this is something is being tested in United States, and of course the forecaster are giving some feedback on that, and this is, as I told you before, very useful. So I would like to take my the last 10 minutes of my talk to talk about the GOESR architecture, because of course this is very nice, but how we can get that information, how we can be prepared to get that information. The basic idea is GOESR is we will have the GOES rebroadcast. We have the direct broadcast. This is the GRB feed. This is what we receive. The GRB, GOES rebroadcast. The basic idea is that the data came, of course, GOES is monitoring, is collecting data. The data is going through the command and control mission data. These data are reprocessed in Wallop Island in Virginia and go back to the satellite, and this information is rebroadcast by the satellite to the direct readout users. So this is something different than the current GOES imagery. So of course, as I show you later, this is completely different. We have the GOES, we have here the mission data stream, and we have here our user receiving station. So this is what we have inside the receiving station, and this is what we have in the ground segment. This is not this is not important for us because this is no responsibility, but this part is our responsibility. We need to have all these components inside our receiving station to get information about the next GOESR. And the most important thing, the new feed, the GRB, is completely different from the current GOES data. So here we have a table with the difference. The polarization for the G bar is linear. Then we go to a dual circular polarized. The receiving frequency is different, and we have data compression. And the most important thing, the data rate for the current feed, it's 2.1 megabytes per second, and we'll go to 31 megabytes per second. So the speed, the data rate is much larger. So the message here is no current G-bar station will have the capability to receive GOESR. This is the bottom line. So if you want to receive GOESR, you need to buy a new station. This is the main message of this slide. So we need to be prepared for that, because buying a receiving station is not an easy process at the governmental level. So we need to start right now if we're going to get GOESR from the first day. And as I told you before, there's a package that we need to have. We need to have to process all the information. And the University of Wisconsin, this is on a slide that James Martin gave me from the University of Wisconsin at Maryland. So they are developing a free of charge processing package for geostationary satellite data. They started a couple of years ago in May 2015 to develop the software package, and I will show you a little bit how this software looks like. So the basic idea is they use the experience they have with the CSPP for the polar orbiter satellites, and of course to use that experience to leverage algorithm developed for GOESR. So these are the benefits, and you can go through the slide to see what we have. So this is the thing we are interested right now. This is with the GOESR AVI, and we have a test version on CSPP GeoGRB software with some test feeds that we can try right now, and we did that at INPE, and the software is working very fine. So this is the first piece of software we need to have to get the imagery from GOESR satellite. The second package is the GeoCAD software. In this software, we will have the products. So if we are interested, for example, rainfall rate, this will be available through this software, the CSPP GeoCAD software. And with this one, we will have the imagery. We can decode the RGB, as I show you here, will become a level 1 product from Abia. This product will be available in NetCDF format. So what we need to run these products? This is something about the minimum hour requirement. We need to do that, and some information about where you can get that software, and go through all the process with the test data, so you can test the data and be prepared once you get the real data to get the information from GOESR. This is the GRB pipe, the output. This is just one channel. This is the output what we have from this package. This is for 3.9 microns. This is just another example for the continental United States. And the GeoCAD is the second package we have right now, is to create the products. So the previous one created imagery, and this one created products. So this is the GeoCAD. This is just for MRI data. This is channel 1. This is an image also, but we also have, this is the software requirement for the GeoCAD software. So we have two different computers, one for CSPP Geo and one for GeoCAD to create the product. So this is something that you need to go through. You have a lot of information, so I suggest to download the presentation and go through all these slides to see exactly what you will need to start working with that. And this is the products that are currently putting inside the GeoCAD, and for sure they will put more in the near future. For example, here we have very nice products like probability of fog, ice water cloud, different products, cloud mass, cloud phase, cloud type, that are also very important for the forecasters. But the point is something that also would like to talk with you is, of course, how much it costs this receiving station, because the previous one, the 4G bar, doesn't work. So you need to buy a new one. And the new one, perhaps for some of the weather service, are pretty expensive. So here we have some kind of alternative mode of disseminating data. Is called GeoNetCast. I know that most of you knows about GeoNetCast, but the important thing is that in the feed of GeoNetCast will be GOESR data. Perhaps not all channels we have in GOESR, not at the full temporal resolution, but for sure there will be some channels inside the GeoNetCast cover, in the GeoNetCast America coverage. So this is also a completely different thing. This is a very cheap station. So this uses the commercial satellites to rebroadcast the information. And of course, if right now there is some kind of survey going through different weather service in Central and South America to decide if they want to get this information as a primary source of satellite information. Depending on how many stations we will have in terms of density, of course it's more pressure to get more data inside the feed. So this is something that you are the users, and you need to decide if this is good for you or not. So, but this is, of course, this is something that we need to consider, because this system is much cheaper than a direct readout station. So this is something that how the GeoNetCast works, and this is the same thing how this working right now, our GeoNetCast, and this is the cost of the GeoNetCast America station. So this is something that you really need to take into account and see if you would like to get GOESR information in this feed, and how much of that information you would use, and if you want to use this system as a primary system of information. because this is something very useful for NOAA and for INPE and for the whole system to decide how we can move forward with the future generation of geostationary satellites. So this is some kind of example of GeoNetCast station. And the last two slides, through these slides, I would like to talk a little bit about a visualization tool. Because of course we have the information, we have everything. And well, the point is how we can visualize, how can visualize the information. So here at CPTech, we are developing a new visualization tool called SigmaCast. This tool will be attached in some point with the GeoNetCast station. So all the information coming through GeoNetCast will be available for this tool. So we can display and process and analyze any image that we will have through the GeoNetCast feed. So this is something also really important, and we are putting a lot of effort on that software, and of course we would like that everybody in our region will use this in the near future. This is some examples of the SigmaCast visualization tool. It's different layers, transparencies, and limits, and of course we will receive feedback. Once we get this out, we would like to get feedback from different users to improve this system, because we know that is very important. So this is some kind of roadmap, what we will expect from now to the launch of GOESR, and what happens if we decide to buy a GBAR station, or if we decide to go with the GeoNetCast America, and what happens if GOESR becomes GOES-East, what happens if GOESR becomes GOES-West, and different actions you need to take into account as a National Weather Service or of Hydrological Weather Service to get ready to use this information from day one. Of course, this is done the previous year when the launch of the satellite will be in April. Right now will be around July, but it's not sure. So you can move this schedule around 6 months, that you will be fine. Of course, this is something that will be available in the presentation. So the message here is download the presentation, read that information. If you need someone from me, just let me know, send me an email. I will write down my email here so I can share with you all the information about this presentation and other information about GOESR. So this is the countdown, and this is some web pages that you can go through and see about the different products. Thank you.